Okay, and so we're adding fractions to the mix here with solving for a variable in terms of other variables. And the first thing that we're going to want to do here is to do what I call the cleanup and simplify both sides of the equation as much as possible. So in doing that, we're going to do the distributive property on the right. We'll get 2/3 y minus 2/3 z. And then notice that we have a denominator of 3 throughout the equation, so we'll multiply both sides by 3. We get 3x is equal to 6 over 3y minus 6 over 3z. We're asked to solve for z, and so we're going to continue with simplifying those fractions. 6 divided by 3 is going to be 2. Y, 6 divided by 3z, is going to be 2z. And so solving for z, we're going to subtract 2y from both sides. We get 3x minus 2y equals negative 2z. We divide both sides by negative 2. And we get negative 3 over 2x minus negative 2 divided by negative 2 is going to be plus 1y equals z. And so we get negative 3 over 2x plus y is equal to z. All right. On to the next, we have x equals 3/5 times y minus z. Okay, so y minus z is popular, it looks like. Okay, so we're going to simplify the right side by doing the distributive property. 3/5 y minus 3/5 z. And so we see that our denominator is 5. We're going to multiply both sides by 5. And we get 5x is equal to 15 over 5y minus 15 over 5z. And so simplifying those fractions, we get 5x is equal to 3y minus 3z. Solving for z, so we do need to subtract 3y from both sides. So we get 5x minus 3y is equal to negative 3z. Need to divide by negative 3. And we get negative 5 over 3 x. Negative 3 divided by negative 3 is going to make a positive 1, y equals z. So negative 5 over 3x plus y. Oops, that came out not the way that I want it. Negative 5 over 3x plus y. Let me pause really quick and check to see what's going on here. So it turns out that Alex just didn't like that I had the x in the denominator with the 3. It wanted it behind the fraction bar there. I do believe you could also put the x in the numerator and it would count it correct, but Alex was picky about not having the x down there with the 3. Okay. Moving on. A little bit of a different style here. We have L is equal to A minus B over 2. Solving for B, you can see that B is being divided by 2, so we're going to multiply both sides by 2. I would do that anyway, because 2 is the fraction in the denominator, or the denominator of our fraction. So the 2's are going to, actually I'm going to do this a little bit differently. I'm going to rewrite this so it makes a little bit more sense to me. So I'm going to put this as being L is equal to A over 2 minus B over 2. And that makes it a little bit easier for me to see what's going on. So we can see our denominator is 2. We're going to multiply both sides by 2. We get 2L is equal to 2A over 2 minus 2B over 2. Simplifying those fractions, we get 2L equals 2 divided by 2 is A, and 2 divided by 2 is 1, so A minus B. Solving for B, we can see that there's a positive A over there with it. We need to subtract A. So we get 2L minus A equals negative B. We don't want negative B, we want positive B, so we're going to divide by negative 1. Across the board there. Negative 2 divided by negative 1, 2 divided by negative 1 is negative 2L. Negative 1A divided by negative 1 is going to be positive A. And then gives us a positive B on the right. So B is negative 2L plus A. Okay, and we'll do one more. And I'm going to make it be that style again. Okay, so we have S is equal to R plus P over 8. So S equals R plus P over 8. We're solving for P. And so I'm going to rewrite this as I did last time. S is equal to R over 8 plus P over 8. I can see our denominator is 8. I'm going to multiply both sides by 8. We get 8S is equal to 8R over 8 plus 8P over 8. Simplifying those fractions, we get 8S is equal to R plus P. Next, we are looking for P, so we need to subtract R from both sides. So 8S minus R equals P. Okay, that's it for that one.